Assalamualaikum, good morning everyone. Today we will finish our chapter 24 nuclear reactions and their applications, and today we will focus on these topics. Radioactive emissions collide with surrounding matter and cause ionization. Ionization radiations will affect our living tissue, and the danger depends on type of radiations, half-life, its biological behavior, how quickly it releases, and amount being released. Even nucleus in reaction involves little or no involvement of electron, but the reaction emit radiation affect the surrounding electron. Okay, the effect of radiations on living tissue depend on the penetrating power and the ionizing ability of the radiations. And the penetrating power is inversely related to the mass, charge, and energy of the emission. And here is the average value of penetrating distance for alpha, beta, and gamma radiation. Okay, for alpha particle, it is massive and highly charged. Remember, the penetrating power is inversely related to the mass, charge, and energy of the emission. So, since the alpha particle, the penetrating power very little, so paper cloth can stop the alpha radiations from external force. It cannot be ingested and can cause internal damage, example, bone fracture. It is for alpha particle. Okay, beta particle or positron, it has less charge and less mass than alpha particle, and it interacts less strongly with matter. The emitter beta more destructive external source because it penetrates deeper than alpha particle. Thick metal and having clothing are required to stop, and it can cause death. For gamma particle, it has no mass, least interactions with matter, and it penetrates more. A block of lead needs to stop it, and gamma ray is the most dangerous because energy can ionize many layers of living tissue. Okay, the molecules can interact with radiation and cause loss of electron from a bond or a lone pair, producing the free radical, a molecule with one or more unpaired electrons. Okay, water and membrane lipids are very susceptible, are very vulnerable to the radiations. For example, here, the water molecule interact with the gamma radiations, producing the free radical and loss of electron from the water molecules. And these radicals will interact with another water molecules, producing another free radicals, and the electron interact with another water molecule, producing another free radicals. And besides, the double bonds in membrane lipids are very easier to be attacked by the free radicals. For example, here, this is the healthy membrane lipids, and this is the damaged membrane lipids. And these free radicals attack the double bond and cause this molecule to lose electron from a bond, and producing the free radical, a molecule with one unpaired electron here. And here is the damaged membrane lipid, and the damage of membrane lipid will cause destructive protective tissue around our organ. Okay, the radioactive material can be found through nature, for example, from the solar system, from water and various food sources, and from atmospheric CO2. Okay, this table shows you the radiation dose from natural and artificial source. Actually, we are continuously exposed to radiations from natural and artificial source. Okay, this column show you the source of radiation for artificials, and this column show you the average dose exposed to radiations, and the largest artificial source of radiations and the one that is the easiest to control is from medical diagnosis technique, especially X-ray. The nuclear dosage, as we can see here, the nuclear dosage radiations is small, but exposure for those living nearby are very high. Here we can conclude that low dose at low risk while high dose at high risk. Okay, this table summarizes the effect of single dose on our whole body, and as we can see here, the effect we increase of the dose, and here we can see that the radiation can affect the DNA mutations, and studies show that either large dose or small dose is harmful. Here are some applications of ionizing radiation. The ionization radiation has been used in devices that destroy cancer tissue, kill organisms that spoil food, control insect populations, and power spacecraft instruments. Radioisotopes are widely used in medical diagnosis and therapy, and even though ionizing radiation can induce cancer, it can also be used to treat cancer. As we can see here, the cancer cells are destroyed by radiation. The radiation can kill microorganisms and increase shelf life of irradiated food. Radioactive nuclide can be attached to other substances which are then said to be tagged, and the fate of this tag can be tracked with a radiation detector and can be used as tracer. Here we can see how radioisotope can be used to observe the specific organ in the thyroid gland. Okay, the radioactive chemical can be ingested and allowed to find their own way to the targeted tissue. As we can see here, the I31 can show you the asymmetry image that is indicative of diseased thyroid gland, and TC99 can show you the healthy thyroid. Several radioisotopes used in medical diagnosis are listed in this table. Positron emission tomography method is used to observe brain structure and function. As we can see here is the brain activity in a normal person, and here is the brain activity for a patient with Alzheimer's disease. Okay, any reaction that release or absorb energy also lost or gain mass. Here is the equations. However, in chemical reaction, the energy change in breaking and forming bond is relatively small, so mass change are negligible. However, in nuclear reaction, the energy changes are very large, so the mass change are easily measurable. Okay, when nucleons form nucleus, the mass is lost and release an energy. While when the nucleus break into nucleons, it requires energy. So meaning that from nucleons into nucleus, so it release energy. From nucleus break into nucleons, it requires energy. So nuclear binding energy is the energy required to break one mole of nucleus into nucleons. 1 AMU equal to 92.5 MeV. Here are the example of question that need you to find the binding energy per nucleon and compare with carbon 12. Here, for example, iron 56, according to the atomic number in previous table, it has 26 protons and the mass number is 56. So to get the neutron, you need to calculate you need to minus 56 with 26 number of proton, mass number minus with the proton, then you will get the neutron, and calculate the mass difference. Since nucleon equal to proton plus neutron, so you need to calculate the mass difference by adding the mass of proton with the mass of neutron. So number of proton times with the mass of H atom represent the proton, plus with 30 number of neutron times with mass of neutron that given to you, minus with mass of ferrum 56, and the mass is given here, then you will get the mass difference. Okay, divide with 56 nucleons, so you get the binding energy per nucleon and compare with the carbon 12. Okay, this graph provides information nuclide stability and two process fission and fusions undergo to form stable nuclide. And from here, we can also see that the nuclide become more stable with increasing mass number up to 60, and after 60, the stability decrease. Okay, there are two ways nuclide can increase their binding energy per nucleon, by fission and fusion. Fission is the process where nucleus can split into lighter one, while fusions from lighter nuclei can combine to form heavier nucleus. As we can see here, the heavier nuclide split into lighter one and release energy and high energy neutron and cause further fission. Okay, as we can see here, the neutrons that are released by fission of other nucleus collide with other fissionable nuclei and cause them to split, releasing more neutron and so on in chain reactions, and the energy release increase rapidly. Okay, the uncontrolled chain reaction can be adapted to make extremely powerful explosion. Nuclear fission can be used to generate electricity, where heat from fission is used to drive electrical generator. Okay, like coal power plant, the nuclear power plant can generate heat to produce steam and turn the turbine and generate electricity. Okay, it has potential to provide electric power plant cleaner than the combustion of coal. That's one of the benefits of nuclear power plant. Okay, nuclear fusion is a source of clean, abundant energy, but it requires extremely high temperature, so it is not practical for nuclear fusion. Sun and star produce energy by nuclear fusion. For example, here in Sun, deuterium and tritium fuse under high pressure and temperature, form stable helium and neutron, producing the sun energy. Okay, at center of star, atom collide and fuse to release large energy, and this energy fuel the next stage of more atom. This how star get energy and make it hot and bright like sun. Even though nuclear power plant can give us large amount of energy, but it also can give us disaster. Remember the disaster of power plant that happened in Fukushima and Chernobyl? There are some limitations of nuclear power plant. Besides, it also can give us problems such as thermal pollution, radiation leak, and disposal waste. In Malaysia, it's unstable. Now it's unstable to build the nuclear power plant since scientists are unable to find way to dispose the waste, and residents also cannot go to their home due to radiation. So I think in Malaysia we are fortunate as we have constant supply of electricity generated through burning fuel, charcoal and hydroelectric power.